Here's a number that should absolutely terrify you. 39. 39 bits per second. According to a 2019 study published in Science Advances, that is the universal transmission rate of human speech. It doesn't matter if you speak English, Japanese, or French. Once you average out the speed of syllables and the density of information, we all top out at roughly 39 bits of data per second. Now, to put that in perspective, an old dial-up modem from 1990 ran at about 56,000 bits per second. Your home Wi-Fi is probably doing hundreds of millions. And yet, you, with your complex emotions, your childhood trauma, your nuance, and your brilliant ideas, you are forcing that entire high-resolution reality through a biological straw that transmits data slower than a pocket calculator from the 70s. We walk around thinking we're these hyper-intelligent beings, but our input-output ports are shockingly bad. We are supercomputers trying to talk to each other using smoke signals. And this discrepancy between the infinite complexity of your mind and the pathetic bandwidth of your mouth is what I want to talk about today. We're going to look at human language not as poetry, but as a system of engineering. Specifically, we're going to look at it as a form of lossy compression. And we're going to contrast it with something that doesn't have this problem, the artificial intelligence concept of latent space. Because once you understand the difference between how you speak and how a machine thinks, you start to realize that almost every argument, every political divide, and every broken relationship in history isn't a failure of empathy, it's a failure of bandwidth. Part 1. The biological bottleneck. Let's start with what happens inside your head before you even open your mouth. When you have a thought, it's not a sentence, it's a texture. It's a high-dimensional event. Let's say you're thinking about a specific memory, maybe the smell of your grandmother's kitchen. That thought isn't just the word kitchen. It's the smell of flour, the hum of the refrigerator, the specific quality of light hitting the linoleum, the feeling of safety, the vague anxiety about getting older. It's all happening at once, firing across billions of neurons. It is a massive, multi-dimensional state. But then you have to tell your friend about it. And here lies the tragedy. You physically cannot transmit that state. You have to perform an act of violence on your own thoughts. You have to crush that multi-dimensional reality into a linear string of noises. In 1948, Claude Shannon, the father of information theory, laid this out mathematically. He described communication as a source, a transmitter, a channel, and a receiver. For us, the channel is the air, vibrating with sound waves. But that channel is narrow. You can't say two words at the same time. You have to serialize your data. You have to put one symbol after another in a straight line. So to fit your grandmother's kitchen into that line, you delete 99% of the data. You strip away the lighting, the anxiety, the smell, and you just say, I miss my grandma's house. That is lossy compression. It's exactly like taking a beautiful, high-resolution RAW photograph and compressing it into a jagged, pixelated JPEG so you can email it. You save space, you save energy, but you lose the truth. And the listener? They don't get the RAW file. They get the JPEG. And then their brain has to do something dangerous. It has to upscale it. They hear the words grandma's house and they paint their own picture on top of it. But their picture has different lighting. It smells different. They might have hated their grandma. So now you think you've communicated, but you haven't. You've just triggered a hallucination in someone else's brain and hoped it matches yours. Part 2. The latent space. Now let's pivot, because we've built something that doesn't have to do this, or at least it does it very differently. I want to explain how modern AI, large language models, actually understand concepts. They don't just look at a dictionary definition. They use something called latent space. Imagine a grocery store. This is the classic analogy. In a grocery store, there is a logic to where things are placed. Apples are next to pears because they're similar. Apples are far away from motor oil because they're semantically different. But they're also far away from milk, which is food, but a different kind of food. If you could map the location of every object based on how similar it is to every other object, you'd have a map of meaning. AI takes this idea and blows it up into thousands of dimensions. When an AI processes a word like king, it doesn't just see a string of letters. It sees a set of coordinates in a massive geometric space. It's a vector. And the coolest thing is that you can do math with these concepts. The most famous example in machine learning is this. If you take the vector for king, subtract the vector for man, and add the vector for woman, the computer lands on the exact coordinate for queen. King minus man plus woman equals queen. That's not poetry. That's geometry. In this latent space, meaning is continuous. Between hot and cold, there's a smooth, sliding scale of millions of points. There's no ambiguity. Everything is defined by its precise distance from everything else. It's a high bandwidth, high-dimensional reality, very similar to the state of your brain before you try to speak. But here's the rub. We humans don't have a USB port. We can't just plug into each other and share the coordinates. We're stuck with the grunt and squeak method. We're stuck with the 39 bits per second. Part 3, semantic entropy. So what happens when high-dimensional beings, us, try to operate on low-dimensional bandwidth? We get noise. We get what I call semantic entropy. Entropy, in thermodynamics, is a measure of disorder. In information theory, it's a measure of uncertainty. Semantic entropy is the uncertainty of meaning. It's the gap between what I said and what you heard. And this gap isn't just awkward, it's dangerous. It destroys civilizations. Let me give you a concrete, historical example of semantic entropy with a body count. July 45. World War II's ending, but Japan hasn't surrendered yet. The Allies issue the Potsdam Declaration demanding unconditional surrender. They are waiting for Japan's response. The Prime Minister of Japan, Kantaro Suzuki, holds a press conference. He is asked what he thinks of the demand. He uses the word mokusatsu. Now, mokusatsu is a high-dimensional word. It's composed of the characters for silence and kill. In the context Suzuki likely intended, it meant something like, "We are withholding comment for now," or "We are ignoring this pending a decision." It was a tactical pause. But the Americans? They didn't have the cultural coordinates. They didn't have the latent space of the Japanese language. They translated mokusatsu flatly as to treat with silent contempt or to ignore entirely. They heard, "We think your declaration is trash and we're ignoring it." 10 days later, the Enola Gay dropped the atomic bomb on Hiroshima. Now, historians debate whether the bomb would have dropped anyway. It probably would have, but that mistranslation, that compression error, removed any possibility of a diplomatic off-ramp. That is semantic entropy. A complex political state compressed into a single ambiguous token, decoded incorrectly, resulting in prompt and utter destruction. And we do this every day. Maybe not with nukes, but with our relationships. You say, "I want more freedom in this relationship." To you, freedom maps to a specific coordinate. You want Friday nights to play poker. To your partner, freedom maps to a different coordinate. They think you want to date other people. Same token, different vectors. Massive entropy, fight ensues. Part 4. The Vector Pinning Protocol. So how do we fix this? We can't upgrade our biological bandwidth. We're stuck with the mouth and the ear until Elon Musk figures out the Neuralink thing. But we can update our software. The prompt I started with mentioned a vector pinning protocol. I love that phrase. It sounds sci-fi, but it's actually a very old idea. It's the discipline of refusing to use lazy, low-dimensional words. George Orwell wrote about this in 1946, weirdly close to the Mokusatsu incident, in his essay, Politics and the English Language. He argued that sloppy language leads to sloppy thinking. When we use vague phrases, we are letting the entropy win. We are conserving metabolic energy at the cost of truth. Vector pinning means taking the time to define your terms. It means paying the thermodynamic cost of explanation. Instead of saying, "I want freedom," which is a blurry, low-resolution JPEG of a word, you say, "I feel confined when we spend every weekend together, and I need 4 hours of solitary time on Friday nights to recharge so I can be a better partner." See the difference? The second sentence takes longer to say. It costs more calories. It requires you to actually know what you feel. But it locks the coordinates. It pins the vector. It eliminates the guessing tax for the listener. It reduces the semantic entropy to near zero. We live in a world that incentivizes the opposite. Social media is designed for maximum compression. Tweets, sound bites, slogans. Make America great again. Defund the police. Believe women. These are powerful tokens, but they are incredibly lossy. They are semantic grenades. Everyone hears them, but everyone projects a latent space onto them. The result isn't communication, it's tribal signal jamming. If we want to actually understand each other, to bridge the gap between your high-dimensional pain and my high-dimensional empathy, we have to stop relying on the default compression settings. We have to be verbose. We have to be precise. We have to act like engineers of meaning, not just consumers of noise. Because right now, the machines are getting better at understanding the geometry of thought than we are. And if we don't learn to speak with precision, we're going to be left behind, grunting at each other in the dark while the AI navigates the stars. Think about that the next time you get into an argument because someone took you the wrong way. They didn't take you the wrong way, you just sent them a corrupted file. If you know someone who's struggling to get their point across, send this episode to them. It might just help clear up the signal.